Okay, this is Discriminant Part 2, and I've got an example written up that we're going to look at. It says, determine the nature of the roots of the square root of 3x squared plus 6x plus 2 root 3 equals 0. So we can just dive right in. They didn't say solve, it just says the nature of the root. So that is typical of a discriminant type question. So I'm interested in examining b squared minus 4 times a times c. And I want to know, is it positive, 0, or negative? So b is 6. So I got 6 squared minus 4 times a. And a is the square root of 3. Okay, times c. Now c is 2 root 3. So we're just going to put the whole thing in there as c. Okay, now I'm going to work this out. We got 36 minus, now 4 times root 3 times 2 times root 3 is 4 times 2 is 8. And root 3 times root 3 is root 9 or 3. So what I have here is 36 minus 24, which is 12, but is good enough to even conclude, oh, it's positive. Therefore, what do we have? We have 2 solutions, or 2 real, if you want to be specific, 2 real solutions. All right, and that's all there is to it. Now, you'll notice the word roots up here. Roots is another word for solutions, okay? And another word that you might run into is zeros. These are interchangeable, and they all mean, zeros comes from the idea that they are the x-intercepts. They are the spot on the x-axis where the function equals 0. So you'll see roots, solutions, or zeros interchanged for essentially the answers. Okay, I'm going to move on to the second discriminant example that I'm doing today. And this one's a little bit of a different question. What it gives you is it doesn't really give you all the numbers. It gives you x squared plus some number k times x plus 2 equals 0. So this is not a specific equation. You know, we don't know what k is. But what the thing says is we're going to determine k. So determine k such that the equation has, and now they're going to tell us exactly how many solutions we want. So determine k such that the equation has 2 solutions. Has 2 solutions. Okay, so how are we going to do that? Well, this is a discriminant question. So what you do is you set up your discriminant. You say, well, 2 real solutions, okay, means that my discriminant, b squared minus 4ac, has to be positive or greater than 0. So this is the same thing as saying we want the discriminant to be positive. Okay, now I'm going to plug in specific to this equation what is b and a and c. So b is this k business. So I got k squared minus 4 times a is 1, and c is 2. Now we want this to be positive or greater than 0. So if I just keep going here and solving, I got k squared minus 8 is greater than 0. Now I'm going to bring the k to the other side. So we're looking at k squared greater than 8. Okay? Now you'll find with inequalities like this, it might be handiest to look at this stuff kind of on a number line. So kind of looking at zones here. Okay, so there's my number line. And what I'm going to do is I'm going to look at exactly when does k squared equal 8. Because those are kind of like the boundaries on my number line. When does k squared equal 8? Well, that's when k is plus or minus root 8. So those are kind of my boundaries here. On the one hand, I got the negative square root of 8. And on the other hand, I've got the positive square root of 8. Now, it breaks my number line up into 3 zones here. And what you're really looking for is which of these three zones makes the inequality true. I think the easiest thing to do is to just take a testing point and plug it in. For example, a number that's in this zone here, something smaller or to the left of negative root 8, might be something like negative 10. Now, if I put negative 10 in here for k, that's going to give me negative 10 squared, or 100. Well, 100 is greater than 8. So this is definitely a true zone down in this area here. In the middle zone, I might try a number like 0. Okay, if I plug 0 in, 0 squared is not greater than 8. So this does not work in this middle area here. Then if I pick a number that's in this zone here, anything greater than root 8, so try something like, I don't know, 12 maybe. Okay, if you put 12 in here, 12 squared, 144, that's greater than 8, so this works. Okay, so if you want, you can show your solution on a number line. Now make sure you make open circles here because there's no equality. It's not k squared greater than or equal to. And so we're going to use open circles and we're going to show, well, it's the numbers on the left side, and over here it's the numbers in this zone, which are to the right side. Okay? Now you can also state your solutions algebraically. You can say, well, and this is the area where k is less than negative root 8, or we've got this zone here where k is greater than positive root 8. So you've got to state your answer either on the number line, you can draw it, or you can actually just state it using algebra. Okay, so this answer actually comes up with not one particular number, but two zones of numbers that will give this quadratic equation up here will have two solutions. Okay, let's do my last example now, and it looks like this. We're going to try to find k so that the following quadratic equation, so 2x squared plus 4x plus k equals 0. There's my quadratic equation, and we want to try to figure this out, figure out what k is, so that we end up with one solution. Not two and not no solution, but one solution. Here's what that means as far as the discriminant. It means the discriminant has to become 0. That's what one solution is. So I'm now going to put in my specific numbers. B is a 4, so 4 squared minus 4 times a, which is 2, and times c, which is k. And we want that to equal 0. So let's go ahead and start solving. That's 16 minus 8k, and we want that to equal 0. I think I'm going to just add the 8k to the other side so that it turns it positive. And then I'm going to divide by 8, so it looks like k would have to have a value of 2. And that's our one and only solution, because this time it's not an inequality, it's an actual equation. We want this thing to equal 0, so we have one and only number that does that. And with that, I am done talking about the discriminant for today.